Hi everyone. This will be a short video trying to clear up some of the misconception people are having these days about this, what's being called new math or common core math, and really it's neither of those, it's just math. And it's just being explained and taught differently these days because over time people get better at teaching things. The real difference here is that 50 or 100 years ago, math was taught as a series of equations or a series of methods to add and subtract and divide. And these days, the emphasis is less on that and more on what we call numeracy, or the idea of understanding what numbers mean and really how to move them and manipulate them and interact with them on deeper levels than just adding them together, for example. So let's start with an example to try to reveal how most people do math in their heads already. So imagine I just rolled these dice, and you want to know what the total is. Now, it would certainly be possible to go through and add them. 6 plus 5 is 11, plus 4 is 15, plus 2 is 17, plus 1 is 18, plus 3 is 21. And that's really how the old style of math would approach this. Right? It would make a big column of numbers and try to add them all up, carrying numbers between the 1s and 10s column. In the modern approach, it's really just looking for groups of 10. So, for example, these two make 10, and these three make 10 more, so that's 20, and then 1. So that is probably how most people's brains already do this. They look for groups of 10 that they can just add up. And that's really what math is these days. Let's look at an actual example that came up in my life the other day. I was preparing to do a big teleconference, and I wanted to get some bids. I knew this teleconference would be about 2 hours, so 120 minutes, and I knew it would have 25 people on it. And I knew that our current vendor charges us 5 cents a minute per person. So if we write out 120 times 25 times 5, the old style of math would involve choosing two of them. Let's do 120 times 5. Let's see, you write it out, and then 5 times 0 is 0. 5 times 2 is 10, so that means I have to carry that 1 up there and put a 0 down here, and then 5 times 1 is 5, and then I have to add 1, which makes 6, so 600. Then we got 600 times 25. So here, 5 times 0 is 0, 5 times 0 is 0, 5 times 6 is 30, and we have to add in the mystery 0. 2 times 0 is 0, 2 times 0 is 0, 2 times 6 is 12. And we draw another line, and we do 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 0 is 0, 3 plus 2 is 5, 1 plus nothing is 1, and we end up with 15,000. So now let's look at the way that's maybe a little more intuitive for most people's brains here. We're going to start off with the same 5 times 120, and with the modern understanding, we're actually going to realize that 120 is just 120. So we can approach this differently. We can now think of it as 5 times 100 and 5 times 20. So 5 times 100 is really just 5 times 1 with 2 more zeros. And then 5 times 20, which is obviously 5 times 2 and an extra 0. So add those together. 500 and 100 is really 5 and 1 with 2 extra zeros. So there we go, 600. Many fewer steps. No carrying of ones. Alright, 600 times 25. Well, again, we're going to notice that it's really just 6 times 100 here, so we can actually just pull those zeros off and deal with it as 6 times 25, which again is the same as 6 times 20 and 6 times 5. So 6 times 20 is 6 times 2 with an extra 0. 6 times 5 is 30. That gives us 150. Put those 2 zeros that we stashed back on there, 15,000. No carrying of ones, no writing of long columns of zeros and mystery zeros, none of that stuff. And it helps kids understand at a deeper level that 120 is 120, or 25 is 20 and 5, and you can treat them separately. They're different columns. So let's go back to something more basic. Let's go back to addition. And I think you'll probably see that the new approach might be what you already do in your head as shorthand. So let's say we want to add 86 and 95 for whatever reason. Now, you can do this way, right? You're at 86, you're at 95, you put a plus there. And then you do 5 plus 6 is 11. You put the 1 up there, and you put the other one here, and then you do 8 plus 9, which is 17, and you add the extra 1, which is 18. You write that there, and you got 181. Okay. Most people probably don't go through all that in their mind. What the modern approach here is to say, all right, 86 is an ugly number. We like things that end with zeros. We like tens. So how many do we need to get up to 90? Well, we know that 10 minus 6 is 4. So we know that we need 4 more points off of that 95. So instead of 86 and 95, we're not even going to deal with those numbers. What we're really going to do is 90 and 91. Right, we're just moving 4 over. All right. Then, well, we can keep that 1 separate over there. So what we're really doing is 90 and 90 and 1. All right, 90 and 90 is easy, right? It's 99, it's 18. Extra 0. Boom. And then, of course, we got that 1 stuff. So, 181. This process is faster for computing these things, but it also, again, is rooted in a deeper understanding of how you can manipulate these numbers. Let's try a subtraction. Let's say it's 34 minus 26. So now, the old system really breaks down. So, okay, we're going to start off with 4 minus 6, which is going to give us negative 2. So that's not going to work. So what you have to do is draw this line through here and write 2, and then move 1 over. So now we're doing 14 minus 6, which is 8. Okay. Now we're doing 2 minus 2, so 0. Okay. So instead of going through all that nonsense, let's look at it the new way. So we got 34, 26. All right. So the real question for subtraction is, what's the difference? How many do we need to add to 26 to get to 34? And that question sets kids up to be able to deal with things like algebra later on. Right? Because in the beginning, if you say, all right, 34 minus 26, you're looking to find out how many you have to add to get to 34. Later on, you can do 26 plus x equals 34, solve for x, all that stuff. But we're looking more basic than that. All right. So to get to 26 to 34, first you got to say, okay, we got to get to 30. So how many do we need to get to 30? Well, we need 4 more. All right. And then how many do we need to get from 30 to 34? That's an additional 4. So we used 4 and then 4, and that's 8. Boom, done. All right, so I think hopefully this little short video has shown some of the differences between the archaic style of math and the modern style of math, or what's often being called new math or common core math, even though it has nothing to do with common core. And I hope it will take some of the fear out of it. I mean, people are afraid because it's this new approach and they're not familiar with it and they're not used to it, so it seems scary. So good luck, and don't be afraid of the new math. Thanks. Bye-bye.